Picture this, a spaceship the length of a compact car, floating alone into the emptiness, 14.5 billion miles from the home that once knew it. Voyager 1, man's most distant and most solitary ambassador, does not just carry the technology of its era but a shard of our essence, a whispered echo of our presence inscribed into metal and computer chips. For almost half a century, it has been voyaging into the unknown, transmitting weak signals that relate the tale of a trip never before undertaken by any living thing. It was designed to watch, not to act, to listen, not to interfere, to stand in silent vigil while the vast dark sea of interstellar space engulfed the final remnants of sunlight. And yet, some recent developments have hinted that Voyager 1 is something more than the quiet observer we used to imagine it was. When NASA sent it up in 1977, the mission had a simple, modest aim: visit Jupiter and Saturn, their moons, and the edges of the solar system, and then disappear into the void. No one really thought that it would still be talking to us in 2025. When it was first released, the internet was not yet a thing, personal computers were commodities that few people owned, and the concept of a handheld phone was a science fiction gadget. Voyager was the state-of-the-art of the late 1970s technology loaded with instruments, cameras, sensors, and a guidance system that would be outperformed by the processing power of a contemporary smartwatch. But where it fell short in computing smarts, it compensated with spotless accuracy and ruggedness. Through the years, it has weathered micrometeoroid impacts, radiation belts, cold temperatures, and the ravages of deep space's harsh environment. Blasted by its aging plutonium power source, it has managed to maintain its instruments well beyond their planned lifetime. Year by year, engineers have faced difficult decisions as to which systems to power down, saving energy like a sailor conserving the last few drops of available fresh water. Even today, its antennas still focus on Earth, transmitting signals that take more than 21 hours to reach. These signals are so weak they might be overwhelmed by the cosmic hum of the universe itself, but our deep space network is still able to pick them up, like listening for the sound of a pin drop from the other side of a continent. The lag makes communication resemble talking to a ghost, with every question punctuated by a near 2 full-day wait for the query to be posed and the response to come back. In 2012, Voyager 1 became the first spacecraft to pass the heliopause, the virtual edge where the solar wind gives way to the frigid plasma between the stars. Beyond this point lies true interstellar space, a region untouched by the sun's influence. Crossing it was like stepping off the continental shelf into the deep ocean. The familiar warmth and pressure of the sun's breath gave way to the frigid, ancient stillness of the galaxy. This moment was not just a geographical milestone, it was symbolic. For the first time, a human-made object had ventured into the region between stars. Nothing we had ever constructed had ever traveled so far. The spacecraft became a mute pioneer on a journey no human eye would ever see up close in thousands of years. Interstellar space is not empty, however. It is charged with cosmic rays, energetic particles traveling close to the speed of light, and chaotic magnetic fields that twist and spin in wild patterns. It is a sea of plasma waves, wandering dust grains, and leftover radiation from events millions or even billions of years past. And Voyager 1's instruments have now started detecting something unusual, something that has excited and unsettled scientists. Voyager's plasma wave instrument detected patterns never seen before in its mission spanning 4 decades. Rather than the steady background hiss of interstellar plasma that was expected, Voyager started detecting pulses. These were not random spikes or noise. They had rhythm, intervals, and consistency, as if they were signals. NASA engineers initially thought it was an onboard fault. After all, Voyager 1's technology is old by today's standards, using memory and processors less capable than a digital keychain calculator. Age creates glitches, and in 2022 the spacecraft experienced a highly publicized failure that jumbled its telemetry. For weeks, it was reporting gibberish data, as if it had lost track of which direction it was headed. That problem had been resolved by painstaking, meticulous remote diagnosis, a process akin to conducting surgery 14 billion miles away. But diagnostics ultimately verified that the unusual pulses now being detected were genuine and originated from beyond the spacecraft. The instruments functioned precisely as designed. That's when the question started. What could produce such a uniform, repeating pattern in the icy emptiness between the stars? Natural events do not often exhibit such accuracy without the influence of some form of cyclical process behind them. The options include exotic astrophysical phenomena, such as plasma oscillations induced by interstellar shocks, to something much more frightening. A shock wave from a supernova remnant theoretically might cause periodic spikes, but there are no known ones along Voyager's present trajectory. Rotating neutron stars, or pulsars, actually do send out periodic radio pulses, but these are at much higher frequencies and would be unmistakable in their signature. The enigma only grew deeper. The timing of the pulses is what really unsettles some scientists. Periodically every 41 hours, Voyager's plasma wave antenna captures a sharp spike. The frequency does not correlate with any recognized spacecraft debris, nor does it correlate with rotation or orbital activity of any known V-region cosmic body. That is, nothing in the immediate vicinity of Voyager should be emitting such a signal. And yet, there it is, steady and unchanging, ticking away like the movement of some clock that none ever knew existed. On the control decks far back on Earth, the staff has started to exchange quiet discussions about scenarios that would have been scotched as science fiction mere years prior. Is this some sort of natural but extremely uncommon interstellar weather phenomenon? Did Voyager just stray into the compass of an undetected magnetic structure within the local interstellar cloud? Could there be compact clumps of plasma floating unseen, interacting with Voyager in ways our computers can't yet comprehend? Or, and this is the daydream that seeps into drunken chats, could the pulses be intentional? Voyager 1 does contain a message to the cosmos, the golden record, a phonograph record inscribed with images, sounds, and salutations from Earth in 55 languages. It was never going to be discovered anytime soon, but if anything, or anybody, was listening out there, Voyager would be the ideal thing to take notice of. Such notions are approached with circumspection. No serious scientist would be eager to jump to the conclusion of extraterrestrial contact without voluminous evidence. The history of astronomy is filled with false alarms, signals later discovered to be natural events, technical malfunctions, or even break-room microwave ovens. And yet the enigma seems to deepen when another piece of information surfaces. The pulse's amplitude has been rising gradually over time, as if whatever is producing them is moving closer. Or possibly as if Voyager itself is drifting closer to their source. Voyager 1, traveling at over 38,000 miles per hour, is heading toward a patch of interstellar space between the constellations Ophiuchus and Hercules. The region is poorly mapped, but models suggest it contains denser interstellar clouds and possibly remnants of ancient supernovae. Might the spacecraft be heading toward something a dead star left behind, a bubble of charged particles, or even an exotic entity like a rogue planet with a magnetic field? Or might it be on an unexpected meeting with something no one has conceived of? There is no turning course, no accelerating or decelerating. Voyager's course is as set in stone as the destiny of a tossed pebble. The signals have initiated a quiet competition among astronomers. Radio telescopes around the globe and in space are being set to the frequencies Voyager has found, hoping to receive an independent confirmation. If they are able to confirm that the pulses are there independent of the spacecraft instruments, it would eliminate any uncertainty about their existence. Some observatories reported that they've already detected similar signals weekly in the same direction, though data is still being checked. There is concern for contamination from terrestrial sources, concern for false positives that might embarrass scientists and harm credibility. But behind closed doors, the buzz is intense. Meanwhile, in a secret corner of NASA's Jet Propulsion Laboratory, there is another, top-secret debate. Voyager's information is available to the public, yet some high-resolution measurements are being kept under wraps until scientists can eliminate interference or intentional spoofing. Space is big, but in the era of deep space communication, it is not inconceivable for signals to be injected artificially. Intelligence agencies have been quietly consulted, not because anyone seriously suspects hostile intent from deep space, but because the pattern's clarity demands absolute certainty before the findings are announced. And yet, the lack of complexity and predictability of the pulses appears to contradict such human tampering. They are too subtle, too exquisitely attuned to the plasma frequencies of interstellar space. It would take colossal expertise, materials, and organization to replicate such an event convincingly, and the question remains, who would take the trouble, and why? If these pulses are indeed natural, their investigation could transform our knowledge of the galactic medium. They may tell us how energy travels in the interstellar space between stars, how cosmic rays interact with plasma, and how the galaxy evolves. If they are man-made, even if constructed by some unknown method of non-alive origin, they would still constitute the first substantiated detection of a structured signal from outside the solar system. Such a finding would be momentous, putting Voyager at the forefront of the greatest scientific discovery in contemporary times. But for others, the stakes are even higher. If the source is of intelligence, then something out there did not only see Voyager 1 but decided to answer. The golden record may have been quietly spinning for decades, its grooves awaiting a stylus that never arrived. But perhaps, just perhaps, it has been heard. Perhaps the message has been interpreted. Perhaps, in some remote part of the galaxy, the conversation has already been started, one we are just now realizing. Today, Voyager travels on, unaware of the arguments it has caused. Its small thrusters fire every now and then to maintain its antenna pointed toward Earth. Its instruments draw the final drops of energy from a dying nuclear core. Engineers say it will stop being able to talk by 2030. Then Voyager will journey quietly for billions of years, carrying our message into the infinity of darkness. Whether these enigmatic pulses will continue until then, or whether they will decrease, leaving only questions, is unknown.